So I just want to give you a little bit of context before the next talk, which is going to be very, very interesting by Frederick. And as Anna said, that's roughly where we are. So the design bit, as we think about it, is somewhere in between having a hypothesis about the analysis, based on the analysis of some accumulated data from the previous iteration of the design cycle or other data acquired by the company. And where you want to get to is having some question that you want to confirm or deny by making a new compound and testing that. So that's roughly the context that we have. And in this design bit, specifically, Marvin Live is currently built out to support mining available information, exploring chemical space, and maybe the starting bits of planning the synthesis of an idea. So here we are in Marvin Live, where we have pre-selected some data that we want to work on. And we configure the alignment tool for us given a protein and the ligand that we compare our ideas to. So based on just what's available here, we can already get an understanding of how this particular compound fits into the binding pocket. We also turn on Campbell activity, which will fetch us the available data. So this was already made, this was already tested, so there is some data for it. And as we start modifying the idea to get to where we want to be, obviously at some point the public data will stop being available. So then we look at predictions, then we start exploring the chemical space. So for that, for instance, you can use calculated properties or another set of tools that you might prefer. So here's just a selection like an MPO chart or a sweet spot visualization. You can have as many of these as you want, maybe 5 or 6 or 8 would be comfortable to use in a single setting. So obviously the goal would be to achieve a good balance of attributes. So we modify the compound until we like what we see in the big combination of all of the tools available to us. When we like something, we can save that. And you can save as many variations as you can think of. So that's one part, that's the design. The second part is that where you have a project, where you have a lead compound and you have your new ideas. So you bring that in from your little private design space, you select just the good ideas and what your original idea was regarding them. But they are hard to compare. So again, we use some tools available to us like calculated properties or and the various descriptors in that, or we look at like different calculated metrics or highest similarity across Schur-Campbell. And then our ideas can be compared, then they can be filtered. So let's just look at compounds that have a high MPO score and sort them based on highest similarity. And what we then really like is that our brand new idea has the lowest similarity across the entire Schur-Campbell set. So given the discussion that the project team has, they can mark it as approved, assign it to a series, assign it to a chemist who will be then tasked with possibly making it. And when we select the data that we want to share or give to them as a task, then that's available as a kind of a report. In this case, that's a PowerPoint report. It has some metadata about the discussion itself, has an index card, and then one page with a compound profile for each item that we worked on. So that's in 3 minutes what this tool is. And there are a couple of moving bits that are important for this to function. One is that the chemist wants to have a very nice balance of attributes, but that's very difficult because either you have too little data or too much. So there needs to be a balance there too. You need just the right amount of information. And some of these tools are like ChemAxon, some are not ChemAxon, some are internal, some are external. So you also need some mechanism to harmonize this big infrastructure. So that's why we have this real-time plugin system where there's an abundance of examples already and new ones are very easy to create based on these for mining or exploring or planning. And as you can see, some of these are green. Those are the ones that have something to do with ChemAxon tools. but a lot aren't, and that's fine. This is vendor agnostic entirely. The source codes are published on the documentation site with a permissive license. The next bit is that, well, you can collaborate with the other chemists on the team on an entire series. So that's what you have seen in what we call the overview mode, where you can collect all the best ideas in the project, and you can challenge them and criticize them and rank them against each other, against the lead compound of the series. So there is always room for improvement. Take out some data, work on it, and when it's good, bring it back into the project space. And you can have as many projects in the application as you want, and there are additional mechanisms that let you have different domains for different advisors, CROs, external people, if you need that. And in each, you can have as many projects as you want. The final concept within the application is the data capture capabilities. So when we saved a really nice idea, that is something we call the snapshot. The snapshot includes a couple of properties, including the author, the molecule source, obviously, a timestamp, all the accumulated data, and a unique ID. And this is then available in various formats as it's needed. So we have our own little virtual idea collection within the application. We can generate reports from this, like PowerPoint, SDF, Smiles, whatever you need. But we can also automatically deposit this data into the ELN, where it becomes like an experiment draft that the synthetic chemist can directly take over then, or put it into relational databases like an Oracle or Postgres database with or without a cartridge. In Instant JChem, it might look like this. So it's a very simple data format. You can see the ID there and the molecule, and then the whole list of metadata items that we track. Author, task, status, URL back to the room, domain, timestamp, what have you. This application is available in two formats. One is the traditional on-premise installation, where you choose your hardware. We can provide containers if that's easier for you. You can be as flexible with the infrastructure as you want, and it comes with the traditional annual perpetual license. But there is also that second kind, the cloud-hosted version, where we can suggest a good service provider like Amazon or Microsoft or Google. All customizations can be done by ChemAxon. We can be as flexible with payment as needed. And there is a single support address for the whole system. So that's Marvin Live, the molecule design and idea management tool. Thank you.